Now we're going to get into our metallic families. The first metallic family is the alkali metals. This is the first column or first group on the periodic table. We call that either group 1 or 1A. And they are the very most reactive metallic family. They react rapidly with oxygen and water. So more things about the alkali metals. They do not exist as elements in nature because they are so reactive. So given a chance to react with something, they will. So anytime you have a free atom that is an alkali metal, it's going to react with something. So it just will not exist as an element. They only contain one outer electron. So when you draw that atom, that last ring has one electron. Uses for alkali metals. Potassium and sodium are in our bodies to stay healthy. You probably have heard of those. Lithium, you may have heard of this as a medicine, and that medicine is used for bipolar disorder. Okay, we're going to watch some videos now.
In this experiment, 1 gram of lithium metal is held inside a glass vial. When the vial is smashed, the lithium falls into a bowl of water. It reacts vigorously with the water to produce milky white lithium hydroxide and hydrogen gas, which can be seen here as bubbles. Since lithium is only about half as dense as water, the metal pieces actually float on the surface and are pushed around by the escaping hydrogen until they are consumed. While lithium is highly reactive, it is the least reactive of all the alkali metals, so the heat and steam it produces is not enough to ignite the escaping hydrogen.
Pure sodium has a silvery white appearance, but tarnishes easily in moist air. Sodium must be handled with gloves because it is highly reactive with water and can easily cause burns. Here, 50 grams of sodium are loaded onto a device on a platform floating on a lake. The device has a pail of water and a hinged arm holding a crucible above it, which can be released from a safe distance. When the sodium is dropped into the water, it will instantly generate a large amount of heat and release a cloud of hydrogen gas. The hydrogen gas will rise and mix with oxygen in the air to form an explosive mixture. The heat from the reacting sodium then ignites the hydrogen and the mixture explodes. The same experiment was repeated at night using 200 grams of sodium, and the reaction is even more spectacular.
In this experiment, a small glass vial containing small pieces of potassium is broken over a bowl of water. The potassium reacts violently with the water and releases hydrogen gas, which ignites almost instantly due to the heat of the reaction. The potassium melts and reacts with water to form liquid droplets of alkali potassium hydroxide, which quickly dissolves in the water.
In this experiment, a small glass vial containing rubidium is broken over a bowl of water. Reacting quickly with the water, the element produces heat. Although it can't be seen, the rubidium and water combine to form a solution of rubidium hydroxide and hydrogen gas.
This experiment, 1 gram of cesium is contained in a glass vial and attached to a device which can be operated from a safe distance. When the vial is smashed, it releases the cesium into a bowl of water. Cesium reacts very rapidly with water to form a colorless solution of cesium hydroxide and hydrogen gas. The reaction creates a large amount of heat and is so energetic that most of the water is hurled out of the bowl by the resulting explosion.
Minute traces of francium are present in this piece of uranium ore. They are generally found in all uranium minerals. Part of the radioactivity given off by this ore is due to decaying francium and can be detected with a Geiger counter. Each click represents one decay event.